Relation. What is relation? If a ordered pair A comma B belongs to R and that R is a subset or equal to A cross B, we call A cross B as Cartesian product. Every element of A is connected to every element of B. But R is depending on the relation. Elements of A will be connected to elements of B. So what is the relation set? R is equal to an ordered pair A comma B such that A comma B is a member of or element of A cross B, where A belongs to capital A, B belongs to capital B, where A is called domain, B is called codomain. Range is the set of all connected elements of codomain. One more question may come. Number of relation from the set A to set B is equal to 2 to the power n of A into n of B. N of A is the number of element in A, number of element in B. N of B is number of element in B. If a relation R is defined on a set A, then for every element A belongs to capital A and A comma A belongs to relation set R, then we call the relation is reflexive. Symmetric. For symmetric, we are supposed to consider two elements. A comma B belongs to given set A. The two element I can select any two from the given set. And if A comma B related to relation set, that implies B comma A also is in the relation set, then we call the relation is symmetric. Transitive. For transitive, we are supposed to consider three elements. A, B, C belongs to capital A, that is given set. And in the relation set, if A comma B, B comma C belongs, and A comma C also belongs to R, then we can say that it is transitive. If R is reflexive, symmetric and transitive, then R is said to be an equivalence relation. For example, if given set is A, 1, 2, 3 are the elements, a relation R is equal to 1 comma 1, 2 comma 2, 3 comma 3 belongs to relation set R. For every element in capital A comma A belongs to R, therefore it is reflexive. Now, when 1 comma 2 is not there in the relation set R, so I need not to check that 2 comma 1 is there or not, but I can straight away say that it is symmetric. Again, listen carefully. If 1 comma 2 is there, I have to go for 2 comma 1 to say that it is symmetric. If 1 comma 2 itself is not there, I need not to go for 2 comma 1. Similarly for other combination, need not to check. Immediately you can say it is symmetric. Now for transitive, I need A comma B, B comma C. Now 1 comma 2, 2 comma 3 or 1 comma 3, 3 comma 2 is not there. Therefore I need not go for checking 1 comma 3 or 1 comma 2. But straight away I can say it is a transitive. Now, according to this set, second line, R is equal to reflexive. There is no 1 comma 2 or A comma B is not there. So we need not check for B comma A, therefore it is symmetric. Similarly, A comma B, B comma C is not there. Straight away I can say it is transitive. Therefore, this relation given set is equivalence relation. The below note clearly I have written. If A comma B belongs to R, then I need to go for checking of B comma A belongs to R and to say symmetry. If not by default, it is symmetry. Similarly, transitive also. Already I have said that. Now, three kind of questions arise. One is prove that, show that. So you have to prove that it is reflexive, it is symmetric, it is transitive. Second type is discuss, verify. So it may be reflexive, may not be. May be symmetric, may not be. May be transitive, may not be transitive, or combination of any one of the three. So you have to go for it, check it, prove it, discuss. Next is some questions comes as divisible by multiple of, both are same meaning. If they are telling it is divisible by 3, then you have to prove that A comma A. If A is divisible by 3, 3 also is divisible, second number B also is divisible by 3. In place of B, we will be using A. That is true fact. Next, A comma B. If A is divisible, A minus B or some notation they will give. A minus B or AB something is divisible, then B minus A also or some operation B star something they will say divisible, that you have to prove. Similarly, if A comma B divisible by 4, for example, B comma C is divisible by 4, then A comma C also will be divisible by 4. You have to go through some example for that. Functions. F colon A into B is said to be a function if for every element of A belongs to capital A, it is connected to a element B. There exists. I have written E reverse, that is to be read as there exists a B belongs to capital B and they are connected. Here A is called domain, B is called codomain. Range. We will be talking about range. Range is the set of all connected elements in B. A is called pre-image of B. B is called the image of A under F. One-to-one function, on-to function, bijective function. Inverse and composite in the current syllabus it's not available. One-to-one function. We have to take f of x1 is not equal to f of x2. Finally, we have to prove that x1 is not equal to x2. Suppose if you are taking f of x1 is equal to f of x2, then we have to prove x1 is equal to x2. Or you can use f of x is equal to f of y. You have to prove x equal to y. If you are taking f of x is not equal to f of y, you have to prove x is not equal to y. onto function. For some of the function, you may be able to immediately find the codomain. For example, x square. X square is always greater than or equal to 0. So you can find the range. If the range is equal to codomain, then we can say the function is onto function. Or you have to take y equal to f of x that belongs to B codomain. Then you have to convert that function as x is equal to g of y. The g of y entirely must be a function of y only. X should not be there in that function. That value must belongs to capital A, that is domain. Then we can say for every x belongs to codomain, sorry, every y belongs to codomain, there exists a x equal to g of y belongs to A. Therefore, it is onto function. Bijective function. If a function is one to one and onto, then we can say it is bijective function. Thank you.